Heating and AC test 5. We got a few minutes here before lunch. I'm going to dive into this thing. And everybody ready? Everybody got it? Test 5? Number 1, heating and AC test 5. Blank is thought to be the chemical chiefly responsible for depletion of the ozone layer.
Carbon.
What?
Chlorine.
Now you guys have been hearing a lot of stuff lately. Chlorine. The reason we're saying that is because refrigerant 12, the old refrigerant that we used for so many years, was difluorochloromethane, and it was a fluorocarbon and all that. Now the carbon, what they're talking about nowadays with this GW stuff and all, and they started out calling it global warming, and since the globe started cooling about 17 years ago and it didn't get warm anymore, they changed that and they started calling it climate change. And they're talking about CO2 emissions there. And if they've got a problem with what I'm breathing out, then they've got a problem. Because I'm breathing out carbon dioxide every day. The animals breathe it out, our cars breathe it out. We got our cars where they're breathing the same thing out that we are. You know that? The stuff that's coming out of the exhaust pipe on your car is the same thing you're breathing out. Nothing wrong with that. The trees and the grass love it. And the atomic weight of carbon dioxide is something like 44. Oxygen and nitrogen, which are the other two principles in our atmosphere, is like 14 and 16 respectively. And so the heavy stuff's going to stay close to the ground. It's not going to cause anything to get warmer up there. Anyway, in 1987, 23 major countries agreed to phase out what at a conference in Montreal? Well, it would be the number, R12. That's C. That's right. Good answer. All right, you got that? All right, now then, 2 technicians are discussing Section 609 of the Clean Air Act. Technician A says it requires that AC technicians be properly trained and certified. Technician B says Section 609 requires recovery and recycling equipment being of approved type. Which technician is correct? And that's C. That's both of them. Section 609, what I'm encouraging each and every one of you guys that are in here doing air conditioning to get your 609 certification. Doesn't cost much to do, not hard to do. You can do it online at home. And when you get that, you're legal when it comes to working on ACs. Now you got to know, as you study that, you got to recognize that it is never okay to squirt refrigerant into the atmosphere. So don't go there. Don't do that. You know, that's a big deal. You know, that's one. It's nasty. Now, one of the things that they were saying that I thought was really funny, the way the law is written, like if you want to work on your buddy's air conditioner at home and you're not certified, let's say you know how to do it but you're not certified, you can work on it at home as long as you don't squirt refrigerant into the air, got me? And also as long as no money changes hands. Or even if he gives you a pack of pork chops, you know, you can actually do it legally as long as you don't charge him. That makes sense? All right then. All right now then. So, but 609 certification is what you want. 608's got to do with house air conditioners. But I've got 609 certification. That's what covers you guys when you're in my school. The certificate that I got on the wall, in the little card I carry in my wallet, it's not nearly as pretty as the one you guys will get. The newer ones are really pretty and attractive and colorful and all that. And it's a good thing to have hanging on the wall. It gives you a qualification, you know, that a lot of people don't have. There's a lot of mechanics that are working on cars every day that don't have a 609 certification. They need to have it. You know, you just about got to have it. When Adam Snap was here, and he was working at the Lincoln Mercury place over there at the time, they said, wow, something just came down from Ford and said we needed to have people 609 certified. And I don't know if I've got anybody in here that is or not. And Adam pulled out his card. He goes, I am. Got it right here. He was the only guy in the shop that had 609 certification, you know. Technician A says the EPA ensures that all SNAP refrigerants are as good or better than R12. Technician B says the EPA checks possible new refrigerants to make sure they're safe to work with. Which technician is correct? All right, now you know, number 4, that's going to be B. Huh? Oh, 3? That's basically both of them. Number 3, that was a C. Yeah. Okay. Now, standards for AC service procedures and equipment have been developed by who? That's actually SAE, the Society of American Engineers. 2 technicians are discussing the retrofit procedure. You know what retrofit is? if you're taking an R12 system and you're putting R134 in it. Hear me? R12 is really hard to get nowadays, and for the most part. And be careful, guys, when you're buying refrigerant, to make sure that you're buying good refrigerant, because you can buy junk refrigerant that's got hydrocarbon gases in it and all kinds of hogwash. You know, they mix all of this cocktail of gases to make something that they think will work. But I mean, if you're getting, make sure you get a good brand of refrigerant if you buy some, even if you're buying it at the parts house. And when I get a tank of it, what I always need to do is use my refrigerant identifier to measure that tank and make sure that it's 100% 134, because sometimes you'll see all kinds of stuff mixed in there that's not supposed to be in there. Particularly, you know, a lot of stuff, it'll may even look like the right brand and everything, but it'll be coming from some oddball country where they're just, you know, cramming whatever they can in there to make some money. 2 technicians are discussed in the retrofit procedure. Technician A says the service ports must be changed to match the new refrigerant. Is he right? They should, shouldn't they? I've seen vehicles come in here, though, with R12 fittings on them, and when I checked them with my identifier, they have 100% 134 in them. But you're really supposed to change out those fittings, right? And what we do is we take on the fittings that I like to use, we take the valve core out, and then we screw our new fitting over the top of that one. See? And it works real smooth.
But on GM car, you got to put some hose.
You got to change your hose because you got a fitting already, but it's leaking. I don't know why that hose isn't here yet. It should already be here. Technician B says a new label must be installed over the old one to identify new refrigerant oil. Actually, both of those are right. There's a lot of places where it's not being done, but you're supposed to put a label on there. And you're also supposed to change your fittings. Mixing 2 different refrigerants does what? Creates a zeotrope, is illegal, makes a contaminated mixture that's expensive to dispose of. Now, some of you guys saw this the other day where I was refrigerant identified one of these vehicles, and it had a percentage of R12 and a percentage of R134. You remember that? It was like 5% of one and 95 of the other. You don't pull that into the big machine. You pull it into the trash tank with the other little pump. See? Get rid of it like that. And the sad part about having that trash tank is nobody wants to take that stuff once you got a tank full. You just got to store it somewhere. You know, can't let it out into the air. You got to put it somewhere where it'll be safe, and where the can won't rust and all that. 2 technicians are discussing the practice of topping off an R12 system. Technician A says this practice is no longer profitable. Technician B says it's not recommended because of ozone depletion. Who's right about that? That's C, both of them. Let me ask you this. What if you could tell by the way, like on a good warm day like today, you pull a vehicle in here, it's checking the air conditioner's not working right, and it's short cycling, which means it's clicking off and on more than it should. That typically means what? When it's short cycling, what does it mean? No, it typically means low refrigerant. You know, because you got a low pressure switch, when it pulls it below, that means it's just low refrigerant. Okay, so you know, let's say you've determined that it's low refrigerant. Okay, now, and it's got, after you've identified it and you determine it's 100% 134, now what are you going to do to bring it back where it's supposed to be? To begin with, I want to know, how long has it been since somebody's put refrigerant in it? I mean, who's worked on it lately? If this is a 2006 model car and nobody has done anything to it for, ever since it was new, and it's a little bit low on refrigerant, the leak that it has is probably going to be so small that you're probably not going to find it. I mean, it's going to be a super, super, super tiny leak. And what you do is what? What are you supposed to do? How can you put the right amount of refrigerant back in it? Well, say that?
Recover all this.
Recover the refrigerant and see what's in there. See how much was in there. Make sure you recover it all. And then you're going to see how much is there. And let's say that it's supposed to hold, 1.8 pounds, and you get 0.6 out of it. Right? All right. That's going to tell you what was in there. And then you do a vacuum on it. And then you put about 1.8 back in it. See, you need to pull out what's in there. So when you put some in there, you'll know you're putting the right amount, and you're not just indiscriminately squirting the juice in there with a can. That don't really work that well. Bless his heart, Demetrius' air conditioner compressor. You got a bad compressor on yours, don't you? That's right. And there was another one, Daniel's brother's car, has got a bad compressor on it. And both of those cars have got scroll type compressors on them. which I got a scroll top compressor. I'm gonna let some of you guys take apart so you can see what it looks like on the inside, you know. But
Is that the one you made me rebuild?
huh?
Is that the one you made me rebuild?
That was a different one. That's what got pistons in it.
Okay.
Yeah, that was I made you work real hard on that one. Did you feel like you were being beat up? Or what? A container of R134A is color coded what?
Yellow.
What color is a bottle of 134A? Like these I've got out here.
Yellow and gray?
No, yellow and gray is the trash tank.
Green.
Light blue, man.
Light blue?
Yep. Light blue. Light blue is the right answer. Any other answer is wrong. If you said that something about it being some other color, then slap yourself. Okay. Number 10. A potential safety hazard when working with refrigerants is A. Container explosion, B. Asphyxiation, C. Frostbite and blindness, or D. All of these. All of these. And who is it that likes to wear their safety glasses up on top of their hat when they've got all this stuff? A lot of people. We just hate these things. Just hate them. Just hate them. Just put them up here because they, you know, that way I'm sort of satisfying the rule. And so, but next thing you know, the refrigerant's not very forgiving if it goes.
Do they fill a prescription safety glasses?
I got mine are prescription. Mine are Z87. That pair of glasses that I wear right here, that's a $500 pair of Z87 safety glasses. Those glasses, and I'm not kidding you, that glass, now I don't know if it'd stay in a frame, will literally stop a bullet.
Where do you get them from?
From Dobbs and Enterprise. I go get my prescription done, and that guy says the way we tell if they put real safety glasses there or not is we put it in a thing, and we take a steel ball, and we drop it from way up and let it bounce off that lens. Yeah, they got to make sure that they're safety glass lenses when they come back from the safety glasses. And if you look on that frame, it says Z87. Now I got side shields that I put on here too.
And you got that little plastic thing you just put up there one break.
Well, if you got refrigerant spraying out, you're a lot better off like this than you are like this. You got me? Like that. So, and most of the time, people don't think much about batteries. I've actually been working with batteries, and I put a wrench on a battery to take it loose and had it blow up. I mean, when I just made one turn on a bolt, and the battery blew up like a piece of dynamite. Boom! And my hand happened to be right there. If it hadn't, you know, eyeballs today. Because in that day, back in 1976, I wasn't wearing safety glasses very much. When I was in the Ford dealership, though, I had safety glasses with side shields on my face all the time. And I don't know at the times they kept me from getting stuff in my eyes. But, and sometimes you'll get stuff in your eyes you didn't expect to. Raising the shop door and dirt falls off the shop door and goes in your eyes, you know. What?
I have bad news about my safety glasses that I was given.
What?
I was using them with a chop saw, and sweat was getting in my eyes, and I couldn't see out of them, so I put them on top of my hat, and I guess they fell off, and the dude was bush hogging behind me, and I found pieces of them.
He must have been bush hogging mighty close.
He was.
Oh, is that right?
As soon as I got done chopping a tree, chopping limbs so he could get under it, he'd do it.
Okay, well, they were probably, you can get some more.
My safety glasses are demolished.
You need to get some more safety glasses. All right, safety glasses are extremely important. When R12 comes in contact with a flame, a toxic gas called what is formed? What is formed? Phosgene. Phosgene gas. Number 12, when working with refrigerants and refrigerant oils, you should A, avoid breathing the vapors, B, avoid contact with your skin, C, both A and B. That's obvious, isn't it? Technician A says butane and propane will work as refrigerants. Technician B says these gases present a fire hazard during service procedures. Believe it or not, on that, they will work as refrigerants. It ain't a good idea to use them, but they'll work. When I was on wheat harvest back in the 70s, my boss man used a butane tank to air up tires. Tires had butane in them. And, I mean, I'm not going to say that I thought that was a good idea, but that's what he did. And that's actually, yeah, that's C, believe it or not. Technician A says the recovery tank used in a recovery system must be checked and certified every 3 years. Technician B says a disposable refrigerant tank should be properly evacuated before disposal. Which technician is correct?
I don't know how many years it's supposed to be checked. So, is it every 3 years?
Yeah. Well, number 14 is the one we're talking about is B, basically. And all that. And you'll find that out, and you're gonna dig into that. And you're gonna burn it in when you're doing your 609 certification. The most common automotive refrigerant prior to 1990 was R12. Yep. R12 worked better than 134, but R134 works pretty good. R1234, which is the next one, doesn't work as good as 134. So they're going to have an additional heat exchanger between the condenser and the evaporator to make it work good. So keep that in mind. In other words, you know what a heat exchanger is? What's a heat exchanger? Has anybody had their hands on a heat exchanger today?
A radiator.
Radiator's a heat exchanger. That's right. Give that man a gold star. Right. Will I give you a gold star? The radiator is a heat exchanger. The evaporator is a heat exchanger. Power steering cooler, anything that basically is going to flow through there, has got fins and air blowing through it or fins and fluid throwing, that's a heat exchanger. And a supercharged vehicle has got a heat exchanger on it that you don't find on anything else. And that would be called an intercooler.
Okay.
An intercooler. It cools the air after the supercharger heats it up.
Turbo got it too.
Huh?
Turbo got it too.
Yeah, some turbos have got it, some don't. I mean, but superchargers will usually not. Well, I take that back. That Buick Park Avenue Ultra that we work on, that's got a supercharger on it, it has no intercooler whatsoever.
I don't think it's been enough pressure.
No, yeah, but anyway. All right, let me see.
From a downfall.
Technician A says R12 refrigerant leached into the atmosphere damages the ozone layer.
See?
Well, so does launching the space shuttle, but we don't do that anymore. Technician B says holes in the ozone layer allow ultraviolet light to reach the earth. And 16 is going to be A and a B. Right.
Gonna be what?
A and B, yeah.
Oh.
Okay. The first worldwide effort to limit the use of ozone depleting chemicals has become known as what?
Oh.
17 is D. The Montreal Protocol. Remember that. You'll hear about that when you take your 609 test. Too much ultraviolet light reaching the Earth's surface results in what?
Okay.
All of the above. Skin cancer, destruction of oceanic plankton, increased instances of cataracts. The ozone layer primarily filters what? Ultraviolet, right? The ozone layer is in which of the Earth's atmosphere layers? Number 20. It's in the stratosphere. Huh? All right. All right, now I'm going to pause for a second. I have to burn that in because you guys won't forget it. You know, if you've been through it once and you feel like, oh, I don't need to go through it again, then you got a big problem. In the automobile, a heat load comes from where?
Engine cooling system.
Now, when you got to think the right way now, guys. Think the right way. The heat load comes from where? Does it come from the sun load on the car? A cold winter day? Engine cooling system?
None of these.
Believe it or not, that one's B. You've got to heat that car, and so the colder it is, the harder it is to heat the car. Am I right? Got me? That makes sense? So that's what you call the heat load. You're gonna have to come up with some heat to heat that car if it's cold.
Okay, so then what is the heat load?
The heat load is basically how they measure what needs to be done. In other words, if you've got a car that's cold and it needs to be heated, that's a heat load. See, well, your house is like that. If your house is too cold, you know, the heat load is measured. This house is this cold, and we wanted to bring it up to this temperature, so we're going to have to do work or burn something or produce heat to bring it up, right? Heat's what has to be produced. Which of the following is a method of handling a cooling load? See these words? This is new stuff now. Number 2, which of the following is a method of handling a cooling load? A, mechanical refrigeration. B, a block of ice. C, evaporating water. Or D, all of these. That's right. A cooling load, see, if you want it to be a different temperature than it is now, and you want it to be warmer, that's a heat load. If you want it to be cooler, that's a cooling load. Got me? Don't forget that.
So you gonna say a block of ice?
A block of ice will cool you. You know what I'm saying?
What's that?
You're cooling it. It's the D. It's all of them. Yeah. Two technicians are discussing evaporative cooling for a car. Technician A says it would increase the RH inside the car. Technician B says an AC system lowers the RH. What do you think about that? That's actually C. Which of the following describes the drawback of mechanical refrigeration? Oil must be added continuously. It takes energy to drive the compressor. R12 must be added continuously. Only one of them is right is B. The only one of them is right is B. They made a little thing that they used to sell on the tool truck when we had carburetors on the cars. We had that little bimetal spring. We needed to cool it off, see if a choke was working right. They had a thing called a choke cooler. And you hook an air hose into that doggone thing, and out of one end of it would come air that was so doggone cold it'd start making snowflakes. And it had no moving parts on it whatsoever. The cool, literally cool. And you see the mechanics pop that thing on, cool itself off. But it had no chemicals, no nothing. It would just say the cold molecules were forced to the outside and went out that end. The other end had warm air coming out of it. We call that a choke cooler. And I said, if you get an air conditioner to work that way, you know where they're going to wind up going with this? They'll do away with refrigerant. And they've got these, you've seen the heated and cooled seats in these new cars. All right, they don't use refrigerant to do that. They use a principle of, heat transfer that's done with some electronics. And so what they're going to do is they're going to wind up putting that stuff in the door panels and the headliner and all that kind of stuff. So you won't even need no air conditioner. You just tell it what temperature you want it to be and it'll just change it. See? So refrigerants eventually are going to leave. And they're going to have other stuff doing this stuff. I got that from the horse's mouth, by the way, from somebody that really knows what's going on. All right. Let's say two technicians are discussing HVAC systems. Technician A says the evaporator moves heat from the passenger compartment to the refrigerant. Is that right? Does the evaporator move heat from the passenger compartment to the refrigerant?
Passenger compartment.
Is where you're sitting.
You can.
That's what it's doing, basically. I mean, don't be bashful, Any answer is better than a wrong answer. No, any answer is better than no answer, huh? I mean, if you go in the wrong direction, we'll steer you in the right direction. Technician B says refrigerant boils inside the evaporator. He's right about that. Both of them. When it's boiling, it boils. And what's the boiling point of R134? 21 below zero. That's where it boils. That's cool, isn't it?
Below zero.
Yeah, 21 below zero is the boiling point of R134. Now, I'm not going to do it because it's not legal to do it, but you can take some R134 and squirt it into a styrofoam coffee cup because of the R factor of that styrofoam, it'll stay liquid. And you can actually wiggle it around, look down in there, and you'll see something that looks kind of like water in there. Now, it's not a good idea to do this because somebody will pick it up and drink it, you know what I'm saying? But you can pour that on this tabletop and it will boil and go away like that was a hot skillet, Now that that styrofoam is amazing in its R factor. You can actually do that. You can take them silly little cans of compressed air you clean your computers with, do the same thing. They turn it upside down, you squirt some in a coffee cup. Yeah, I freeze stuff with that, All right. Cat burglars do that, I guess.
I bought an air conditioner the other day and I finally found out I finally read it and actually knew what BTUs was. It had like 5,400 something.
Yeah, British thermal units. All right. Okay, when an AC compressor is operating, the compressor, what runs hot? Inlet, outlet, A and B, or neither A and B? What's hot, the outlet or the inlet? Think about what the discharge is. Discharge outlet, right? I'm on number 7.
Low pressure would be the outlet, right?
I skipped over 6. In an AC system, refrigerant changes state from a blank in the evaporator. What is it? What did we just say a few minutes ago? Gas to a liquid. Yeah, remember it. No, I'm sorry. I'm wrong. I gave you the bad answer. It changes from a liquid to a gas. That's correct, because it's evaporating. I had condenser on my brain, and evaporator is what was on the page.
Like the low pressure side, would that be the inlet?
Low pressure is the big line.
I'm saying, that's the inlet?
That's the suction line, inlet, yeah. That's right.
So the outlet would be the...
The outlet's going to be the hot side, that's right. That's exactly right. Technician A says some devices generate heat by compressing gas to a higher pressure. Technician B says some devices generate cool air by allowing a compressed gas to expand. Number 8, SC. The temperature of the refrigerant that leaves the compressor on the discharge side should be what? Should it be cool, cold, warm, hot. It should be hot. You're gonna burn your hand. All right, compressing a vapor does what? A, increases the pressure and decreases the temperature. B, increases the pressure and increases the temperature. C, decreases the pressure and decreases the temperature. I hate these kind of questions. All right, that's basically B. Increases the pressure and increases the temperature, and that's not too hard. In a hybrid vehicle, heat may be added to the heater by doing what? Hybrid vehicle, since the engine's not always running, and you need heat.
Extra heater for it?
Yeah, you're going to wind up having to, huh? What?
Wait, what'd you say?
Number 11? That's going to be B.
Oh.
A TE device. A PTC ceramic element, excuse me. Let's see. Heated seats may use any of the following except, number 12 is D, circulated hot water. You're not going to have circulated hot water going through the seat and burn your buns, right? Okay. Yeah. I tell you what I did have, though. I had a 67 Chrysler New Yorker, and the rear window defrost had a heater core back there and a fan. And there was heater hoses running from the engine underneath the carpet inside the car all the way back to that back heater core. And I was going to ESJC over there right after graduating from high school, and I was driving around that big loop behind the high school, and one of them heater hoses busted inside the car and filled the whole car up with steam. I couldn't see nothing, you know. I mean, that was crazy. Hot water running through the car, going to the heater core in the back. Those Chrysler, boy, I'm telling you. Anyway, that was a crazy thing. Let's see.
But you did had a lot of coolant.
Huh?
But you held.
Yeah, it used a lot of coolant. Okay. In a CO2 R744 system, the high side pressure is above the critical pressure. That means what? Now, this is an interesting question here. You know why CO2 air conditioning systems, we all talked about paintball, right? You shoot your paintball gun, it gets cold. Say, well, can't they use that for refrigerant? You got to have like 2,000 pounds of head pressure to make the CO2 work as a refrigerant. Number 13, the answer to that one is A, CO2 will not condense to a liquid form. That's what's going on whenever the high side pressure is above the critical pressure. Have you ever noticed this? I don't know if you've ever seen this or not. Let me ask you this. If I hung my gauges on a vehicle that I was charging up, and I fired it up, or maybe one that was causing issues, you know, there's a pop-off valve on that compressor. If the pressure goes too high, that pop-off valve will go, and you'll see refrigerant go out. And sometimes that'll happen if the condenser fan doesn't work on one that's got an electric fan. If the head pressure will go up too high, and that pop-off valve on that compressor will go. It's made to keep, you know, as for protection. And so, if you actually, if somebody just puts refrigerant in there with a bunch of air, like if the system went atmospheric because they changed out the accumulator, they shot a bunch of air in there, there's a very good possibility then the air conditioner compressor would start acting just as a big air compressor, and since air is not going to condense into a liquid, the pressure is just going to go really, really high. See what I mean? I mean, like immediately, you'll crank it up. Sometimes you'll see them, in extreme cases, you'll see it go like 500 pounds within, 15 seconds of turning on the AC. So be aware of that kind of thing. And that's also dangerous because you could have something, go boom on you. Okay, so what are two things that are accomplished in the condenser? Somebody talk to me. You guys are not.
Liquid.
Let's say two things. Yeah, you're going to have recycles the gas back to a liquid. That's right. What else?
Move the
latent heat. Yeah. So.
C.
And so that's actually going to be 14. It's going to be C. C. Both. In this diagram of a condenser where the refrigerant enters point A and leaves point D, what is the state of the refrigerant at point C? And that's a picture of the diagram. And that's point C. You got it?
Changing from
Huh? 15? That's actually, yeah, change it from a gas to a liquid. You got to recognize that's a condenser. As the refrigerant passes through the condenser, it condenses from a gas to a liquid. Okay, number 17, the compressor in an AC system is needed to do what? Make the gas hotter than the ambient air, keep the refrigerant circulating, increase the gas pressure, all of the above. Okay. We got 4 more questions. No, 3 more questions. Most cars use what to warm the passenger compartment? Huh?
Cooler.
Most cars. Why do they say most cars?
Some don't have
Huh? Why do they say most cars instead of all cars? Have you ever seen, you know, it's these little Volkswagen station wagons called a 411. You ever seen those little 411 Type 4 Volkswagens that they came out with years ago? They came after the bug. They were in the real early 70s. Well, those things had a gasoline heater. And what you would do is, it had a timer on it. And this is crazy. Have you seen little heaters like construction people use? They'll mist this fuel, and it's like a turbine heater sort of thing. All right, now the Volkswagen 411 had one of those dadgum things on it, and it had a timer. You turn it. Let's say that you're in a cold Northland, wherever. You go out here and you turn that timer. It's a 45-minute timer, and as soon as you turn on that timer, it fires up that heater, and that heater starts using gasoline from your gas tank. It's got a little thing that if the gas tank's lower than a certain level, it won't draw any, so it's not going to run your car out of gas. They don't use much anyway. And it pulls gas out of there, and it mists it past the spark plug, and then it blows, not gasoline fumes, but it blows the heat that's created by that, burning gasoline into the heater. And now you go out there 45 minutes after you get in there, it's just toasty warm in that car. Of course, it cuts off after 45 minutes, But it'll warm that thing up. All your glasses melted away and everything looks good. I mean, but anyway, the reason that I know about that is I had to work on one of them doggone things at the Volkswagen place. The stupid thing wouldn't work. And so that spark plug wouldn't fire. It had a little, thing to fire the plug. And I put a condenser on it, which was bad, and got the spark plug to fire and got the heater to work. And that was a crazy thing. So most cars use blank to warm the passenger compartment. That was it. Now, let me ask you this. You notice that diesel engines take a long time to get warm, don't they? So they have to do something to heat them up quicker. And basically what they used to close off one side of the exhaust and make the engine work harder to warm it up on the older power stroke diesel. And then they started using your variable geometry turbocharger. They'd close it off some to make it get hot quicker. In an evaporative cooling system, evaporating 1 pound of water absorbs how many BTU? We talked about this the other day. Do you remember it? In an evaporative cooling system, evaporative meaning it uses water as its refrigerant. You run that water. I've got an evaporative cooler over here in the other shop that we don't use much anymore. It costs about $1,400, and it pumps water and it trickles down through this porous cardboard, and it pulls air in through that and blows it out, and it's 15 degrees cooler than the air in the shop. Now that thing it's always leaking. It's always a mess. It's always in the way. It's got to have a water hose hooked to it. It's a pain. Yeah.
Is that the complete cycle?
Huh? On an evaporative cooling system, evaporating 1 pound of water absorbs 970 British thermal units. And finally, in this diagram of an evaporator, what's happening to the refrigerant in point B? And there it is right there. There's the picture. In point B, what is happening?
Condensing.
That's the evaporator, isn't it?
Well,
Is it changing from red to blue? It's boiling, y'all. That's what we talked about earlier. Don't play dumb with me. All right. That puts us close enough to where we can go to lunch. See you guys back at